This is the Edexcel Extended Math Certificate Level 2 Paper 2 from the Specimen Set 1. Question number 1. Part A. Factorise fully 3 multiplied by 2x plus 1 squared, subtract 9 multiplied by 2x plus 1. From the 3 and the 9, 3 is the highest common factor. From the 2x plus 1 squared and the 2x plus 1, 2x plus 1 is the highest common factor. So we have 3 multiplied by 2x plus 1 multiplied by, 3 multiplied by 2x plus 1 multiplied by 2x plus 1 gives us 3 multiplied by 2x plus 1 squared, and 3 multiplied by 2x plus 1 multiplied by negative 3 gives us negative 9 multiplied by 2x plus 1. So we have 3 multiplied by 2x plus 1 multiplied by 2x plus 1 subtract 3. And 2x plus 1 subtract 3, that is 2x subtract 2. So we have 3 multiplied by 2x plus 1, and if we consider this 2x subtract 2, we can factorize out a 2, and then inside of a bracket we'd have x subtract 1. 2 multiplied by x subtract 1 gives us 2x subtract 2. So we have 3 multiplied by 2x plus 1 multiplied by 2 multiplied by x subtract 1. 3 multiplied by 2, that is 6. So we have 6 multiplied by 2x plus 1 multiplied by x subtract 1. Part B. Hence or otherwise simplify fully 3 multiplied by 2x plus 1 squared, subtract 9 multiplied by 2x plus 1 over 4x, subtract 8x squared plus 4. For the numerator, we can use the result in part A. Therefore, for the numerator, we have 6 multiplied by 2x plus 1 multiplied by x subtract 1. And for the denominator, we can factorize 4x subtract 8x squared plus 4 as 2x plus 1 multiplied by 4 subtract 4x. So the numerator stays as it is, as 6 multiplied by 2x plus 1 multiplied by x subtract 1, and we still have this 2x plus 1, and the 4 subtract 4x, I can factorize out a 4, and I can also factorize out a negative 1, so I have minus 4, and then minus 4 multiplied by x subtract 1 gives us 4 subtract 4x. The 2x plus 1 over the 2x plus 1 simplify to 1, and the x subtract 1 over the x subtract 1 simplifies to 1. Therefore we have 6 over negative 4, which is negative 3 over 2. Question number 2. The nth term of a sequence is given by 0.05 n squared, subtract 3.2 n plus 51.1. Find the sum of the negative terms of this sequence. Show clear algebraic working. Let's begin with this 0.05 n squared, subtract 3.2 n plus 51.1. What we can do is complete the square of this. To begin with, let's factorize out a 1 over 20. So we have 1 over 20 multiplied by n squared, subtract 64n plus 1022. So we have 1 over 20 multiplied by, now here, if we have n squared subtract 64n, we can rewrite this as n subtract 32 all squared, but then we need to take away the square of 32, and then we still add on the 1022. So we have 1 over 20 multiplied by n subtract 32 squared, and negative 32 squared plus 1022 is negative 2. And if I expand the brackets, we have 1 over 20 multiplied by n subtract 32 squared, subtract 0.1. Let's see which values of n give us a negative value. What we can do is set this less than 0. So we have 1 over 20 multiplied by n subtract 32 squared subtract 0.1 is less than 0. Therefore, n subtract 32 squared is less than 2. So, to find out the values of n which satisfy this inequality, we have n equaling 31, 32, and 33. If I substitute these values of n into the left-hand side, I get something indeed less than 2. So what we need to do is find the sum of the negative terms of this sequence. What we are required to do is substitute in these values of n back into the original sequence 0.05n squared subtract 3.2n plus 51.1. So, for the sum, we have 0.05 times 31 squared subtract 3.2 multiplied by 31 plus 51.1 plus 0.05 times 32 squared subtract 3.2 times 32 plus 51.1 plus 0.05 times 33 squared subtract 3.2 times 33 plus 51.1, and this is all equal to negative 0.2. Question number 3. A triangle has vertices A with coordinates negative 4, 2, B with coordinates 7, 9, and C with coordinates negative 3, negative 6. You have to work out the size of angle ABC. Give your answer correct to 3 significant figures. Well, here is triangle ABC, and here is the angle ABC. What we can do to find the angle ABC is find the lengths AB, BC, and CA. Let's begin by finding the length AB. For AB, that's equal to the square root of 7 subtract negative 4 squared plus 9 subtract 2 squared, which is equal to the square root of 170. Let's show that on the diagram here. Let's now work out what BC is. BC is equal to the square root of negative 3 take away 7 squared plus negative 6 take away 9 squared, which is equal to the square root of 325. Let's show this on the diagram here. And CA, that's equal to the square root of negative 4 subtract negative 3 squared plus 2 subtract negative 6 squared. And this is equal to the square root of 65. Let's show this on the diagram here. Now, for us to find out what the angle ABC is, we can use the cosine rule because we have 3 lengths. Hence, the cosine of ABC is equal to square root of 170 squared plus square root of 325 squared subtract square root of 65 squared over 2 multiplied by the square root of 170 multiplied by the square root of 325. And working this out, we get 0.914, etc. Therefore, ABC is equal to the inverse cosine of this, which is equal to 23.8 degrees to 3 significant figures. Question number 4. Find an equation of the straight line that is perpendicular to 2y plus 3x equals 7 and passes through 6, negative 4. To begin with, we have our equation 2y plus 3x equals 7. And if we rearrange, we can see that 2y is equal to negative 3x plus 7, and if I divide both sides by 2, we can conclude that y is equal to negative 3 over 2x plus 7 over 2. So the gradient of this straight line is negative 3 over 2. We want to find an equation of a line that is perpendicular to this equation that passes through this point. So the perpendicular gradient of this is the negative reciprocal of negative 3 over 2, which is 2/3. And if we use the point 6, negative 4, we have y subtract negative 4 equals 2 over 3 multiplied by x subtract 6. Therefore, y is equal to 2/3 x subtract 8. Y equals 2/3 x subtract 8 is perpendicular to 2y plus 3x equals 7 at the point 6, -4. Sol buys fiction books and non-fiction books. He has a maximum of £900 to spend on these books. Sol buys fiction books for £1.50 each and non-fiction books for £2 each. Let x be the number of fiction books he buys. Let y be the number of non-fiction books he buys. Part A. Use this information to show that 3x plus 4y is less than or equal to 1800. If fiction is £1.50 each and non-fiction is £2 each, and we have a maximum of £900 to spend, that means we have 1.5x plus 2y is less than or equal to 900. And if I multiply both sides by 2, we end up with 3x plus 4y is less than or equal to 1800. A second constraint is x is greater than 0 but less than or equal to 400. Part B. Explain this constraint in context. The number of fiction books is greater than 0 and less than or equal to 400. Part C. On the grid below, identify the feasible region that satisfies the three constraints. 3x plus 4y is less than or equal to 1800, x is greater than 0 but less than or equal to 400, and y is greater than 0 but less than or equal to 300. Now, let's focus on this 3x plus 4y is less than or equal to 1800. To draw that line, we need 2 points. Now, when x is 0, we have 4y equals 1800, meaning when x is 0, y is equal to 450. Let's choose another point, such as x equals 400. In this case, we have 3 multiplied by 400 plus 4y equals 1800. And so if I do 1800 subtract 3 times 400, which is 600, and then divide that by 4, I get 150. So when x is equal to 400, y is equal to 150. So if I draw that line, we have this line here. Then we have x being in between 0 and 400. That is shown in red. And then we have y being in between 0 and 3. That's shown here. And so therefore, for the feasible region R, that's shown here. Sol sells all the books that he buys. He sells the fiction books for £3.50 each and the non-fiction books for £6.50 each. Let the objective function P be the profit Sol makes from selling all the books. Part D. Write down P in terms of x and y. Well, we know from the question, Sol buys fiction books for £1.50 each and non-fiction books for £2 each. So for the profit function, in terms of the x's, the profit for the x's will be £3.50 subtract 150, and for the non-fictions, that's in terms of y's, that's £6.50 subtract £2. Therefore, the profit function v is given by 2x plus 4.5y. Part E. Work out the maximum profit that Sol can make from selling all the books. Well, what I need to do is use a value of P that 2 and 4.5 go into, such as 180. So if I let P equal 180, we have 180 equals 2x plus 4.5y. Now, when x is 0, y is 40, and when y is 0, x is 90. So what we're going to do is draw this straight line. 180 equals 2x plus 4.5y. That is shown here. Now, we need to find where the maximum occurs. So if I get my ruler and align it with this line here, and if I slide up, you see the maximum is over here. The maximum is at 200, 300. So the maximum at 200 and 300 will give us a maximum profit. So the maximum profit is equal to 2 multiplied by 200 plus 4.5 multiplied by 300, which is 1750. Question number 6. Here are the first few rows of Pascal's triangle. We see that here. Part A. Expand and simplify a plus b to the power of 4. Well, here we'd have to use this row here. So I have 1a to the power of 4 plus 4a to the power of 3b plus 6a squared b squared plus 4ab cubed plus 1b to the power of 4. The result is shown here. In the expansion of kx plus 5 to the power of 4, the coefficient of x squared is double the coefficient of x. Given that k does not equal 0, part B, work out the value of k. Here I can see that a is kx and b is 5. So I have kx to the power of 4 plus 4 multiplied by kx cubed multiplied by 5 plus 6 multiplied by kx squared multiplied by 5 squared plus 4 multiplied by kx multiplied by 5 cubed plus 5 to the power of 4. Expanding and simplifying, we have k to the 4 x to the 4 plus 20 k cubed x cubed plus 150 k squared x squared plus 500 kx plus 390,625. I know that the coefficient of x squared is double the coefficient of x, so I've got the coefficient of x squared, 150 k squared, which is equal to twice the coefficient of x, so I've got twice 500k, meaning k is equal to 20 over 3. Question number 7. Prove that 6x squared subtract 6x plus 10.5 is positive for all values of x. To begin with, we have 6x squared subtract 6x plus 10.5. And from the x squared and the x term, let's factorize out a 6. So we have 6 multiplied by x squared subtract x, and then we add on the 10.5. Now for this big bracket, let's complete the square. We have 6 multiplied by. Now if I complete the square for x squared subtract x, I have x subtract 1/2 squared. And I subtract from this the square of 1/2. And then we add on the 10.5. So if we expand and simplify, we have 6 multiplied by x subtract 1/2 squared, and then we have negative 1/2 squared multiplied by 6 plus 10.5, which is 9. Therefore 6x squared subtract 6x plus 10.5 is equivalent to 6 multiplied by x subtract 1/2 squared plus 9. And we want to show that this is positive for all values of x. So the 6 multiplied by x subtract 1/2 squared, that's greater than or equal to 0. And the 9 is greater than 0, meaning 6 multiplied by x subtract 1/2 squared plus 9 is greater than 0. And if that's the case, we can conclude 6x squared subtract 6x plus 10.5 is greater than 0 for all real values of x. Question number 8. F of x is equal to tan x, and g of x is equal to negative f of x subtract 90. Part A, on the grid, sketch the graph of y equals g of x for x being in between negative 180 and 360 degrees. Now, to begin with, here we have the graph of y equals tan x. And what you'll notice is we have asymptotes are x equals minus 270, minus 90, 90, 270, etc. Now, if we have x minus 90 in a bracket, we need to shift everything over to the right by 90 degrees. And in doing so, the asymptotes will also shift by 90 degrees. So here, the new asymptotes are at minus 180, 0, 180, 360. Now, if we have minus the tan of x minus 90, we need to flip this graph in the x-axis. So we end up with the graph shown here. And now we need to restrict the domain to minus 180 to 360. And that is shown here. Hence, here is the graph of y equals g of x. The diagram below shows a sketch of part of the graph of y equals h of x, where h of x equals x cubed plus ax squared plus bx plus c. We see that graph here. The graph with the equation y equals h of x is translated using the vector 3, 0, and then stretched parallel to the y-axis with a scale factor of 2 to give the graph of y equals d of x. Part B. Find an equation for y equals d of x. Well, to begin with, we have an x solution at minus 6, an x solution at minus 2, and an x solution of 2. So, h of x will equal x subtract negative 6 multiplied by x subtract negative 2 multiplied by x subtract 2. And if we simplify, we have x plus 6 multiplied by x plus 2 multiplied by x subtract 2. Now, to find out what d of x is, well, we have a stretch scale factor 2 in the y direction, so we have twice, and then we translate with vector 3, 0, so we need to take away 3 from each of these brackets, meaning we have x plus 6 subtract 3 multiplied by x plus 2 subtract 3 multiplied by x subtract 2 subtract 3. And if we simplify, we have twice x plus 3 multiplied by x subtract 1 multiplied by x subtract 5. Therefore, d of x is equal to 2 multiplied by x plus 3 multiplied by x subtract 1 multiplied by x subtract 5. Question number 9. ABCDEFGH is a prism with a cross-section in the shape of a trapezium. AB equals DC equals EH equals FG equals AD equals BC equals 60 centimeters. The area of the cross-section AFED is 1230 centimeters squared. J is the midpoint of HG. M is the center of the square base ABCD. We have to calculate the size of angle FMJ. Give your answer correct to 1 decimal place. Well, here is the angle we need to work out. We need to work out the angle FMJ. We've got M, which is the midpoint of the square ABCD, and we've got J, which is the midpoint of HG. And so far we also know that the area of this cross-section is 1230 centimeters squared. To begin with, we've got the square ABCD with each side being 60 centimeters, and you'd also see that M is the midpoint of the square ABCD. So what we can do to begin with is find out what AC is, and that will also equal BD, and that's equal to the square root of 60 squared plus 60 squared, which is 60 root 2. And therefore, AM, which is also equal to BM, which is also equal to CM, which is also equal to DM, that's equal half of 60 root 2, which is 30 root 2. As a decimal, that's 42.2, etc. Now, I've got this trapezium. I've got 60 for AD and 8 for AF. The area will be given by 1/2 times ED plus 8 multiplied by 60, and this is equal to 1230. And if that's the case, ED, which is also equal to CH, that's equal to 33. What I can now do is find out what EF is, and I can form a new triangle with EF and some portion of the length ED. So we've got this triangle here, and this length will equal the 33 subtract the 8, which is 25, and this length will remain as 60. So now we can find EF. EF, that's equal to HG, which is equal to the square root of 25 squared plus 60 squared, which is equal to 65. So this length is 65, so now we can find JG. JG, that's half of the 65, so 65 over 2 is 32.5. So here is the top part. We've got J over there, we've got F over here, and this length is 32.5. Now if we go back to our blue triangle over here, we need JF, we need MF, and we need MJ. So what we'll do is we'll find out what FJ is using Pythagoras. That's equal to the square root of 60 squared plus 32.5 squared, which is 68.2. Now if we go back to our diagram, MAF, that's a right angle triangle, and we already know what MA is, and we also know what AF is, and we can find out what the length MF is from that. So here is the triangle AMF. So AM is 42.4, we worked that out earlier. We've got AF, which is 8. So now we can find out what MF is. MF is the square root of 42.4 etc. squared plus 8 squared, which is 43.1 etc. Now in this triangle we have MF, we have FJ, we need MJ. So here is a triangle with MJ on it. This length over here, well, let's think about what we're doing. We're going here. So we've got half of the length of 60 for this bit, and then we have a certain bit going up. So we have 60 over 2, which is 30. And for this length, well, how much do we go up by? Well, that's the average of this bit and this bit. So we have 8 plus 33 over 2, which is 20.5. Meaning, MJ, that's the square root of 30 squared plus 20.5 squared, square rooted, which is 36.3, etc. Now, here is the triangle FMJ. We want to find out the angle theta, which corresponds to FMJ. We know that MJ is 36.3, etc. We've worked that out. MF is 43.1 and FJ is 68.2. So this angle can be found by using the cosine rule. So cos theta will equal 36.3 etc. squared plus 43.1 etc. squared subtract 68.2 etc. squared over 2 times 36.3 etc. times 43.1 etc. And working this out, we get negative 0.469 etc. So theta will equal 118.0 degrees to 1 decimal place. Question number 10. The diagram shows an equilateral triangle of side length 2a centimeters. Part A. Use this triangle to prove that tan 30 equals root 3 over 3. So each length is 2a, and we've got this angle 60 degrees because it's an equilateral triangle. So the first thing we'll do is we'll split this triangle in half. So we've got two right angle triangles. So if this is 60, this will be 90, meaning this angle here will be 30 degrees. And if this length is 2a, half of this will simply be a. Now we can find out this length here, and we can do that using Pythagoras. We have the square root of 2a squared subtract a squared, which is equal to a root 3. So here we have a root 3. Now we want to show that tan 30 degrees equals root 3 over 3. Now tan is equal to opposite over adjacent. We've got opposite and adjacent. So tan 30 degrees equals opposite a over adjacent a root 3. So this simplifies to 1 over root 3, and if I rationalise this, we end up with root 3 over 3. Part B. Solve 3 cos squared x plus 4 cos x plus 1 equals 0 for x being in between 0 degrees and 360 degrees. Give your answers correct to the nearest degree where appropriate. So, what we can do is factorise the left hand side of this quadratic, and in doing so, we have 3 cos x plus 1 multiplied by cos x plus 1 equals 0. So if I solve, I've got 3 cos x plus 1 equals 0, meaning cos x equals negative a third, and cos x plus 1 equals 0, meaning cos x equals negative 1. So now if I solve cos x equals negative 1/3, I will end up with 109 degrees. Now to find the next value, I need to do 360 minus 109, which is 251. Now, if I work out the value of x from cos x equals negative 1, I get 180. So x equals 109, 180 and 251 in this domain. Question number 11, part A. Complete the table of values for y equals 1 over x. So we've got various values of x and we need to find the corresponding y value. So to begin with, when x is 0.5, 1 over 0.5 is 2. When x is 1, 1 over 1 is just 1. When x is 1.5, 1 over 1.5 is 2/3. When x is 2, we've got 1 over 2. When x is 2.5, we've got 1 over 2.5, which is 2 over 5. When x is 3, we have 1 over 3. Here is the completed table. Part B. Use the table of values and the trapezium rule to find an estimate for the area of the region under the curve with the equation y equals 1 over x and between x equals 0.5, x equals 3 and the x-axis. Use 5 strips of equal width. Give your answer correct to 3 significant figures. And here we have the trapezium rule. To begin with, we need to find out what h is. Now h is a constant value. To find h, we need to find the difference between each of the x values. And you will find that is 1/2. Now I'm going to label these y values. I'm going to label them in order. We have y0, y1, y2, y3, y4 and y5. You'll notice y0 is the first y value of 2, and y5 is the final y value, and anything in between, shown in green, is y1 to y4. So, using the formula, the area is approximately equal to 1/2 multiplied by h, which is 1/2, multiplied by, now here we've got y0, which is 2, plus twice everything that's in the middle, so we have twice 2/3 plus 1/2 plus 2/5 plus 1/3, which is yn. And if we work this out, we get 1.87 to 3 significant figures. Question number 12. There are only green sweets, blue sweets and red sweets in a jar. There are 12 green sweets. The number of blue sweets is twice the number of red sweets. 2 sweets are taken at random from the jar. Given that the probability that both sweets are green equals 22 over 925, we have to work out the probability that one sweet is blue and one sweet is red. What we're going to do is let the number of red sweets equal x. And if blue is twice red, that means blue is equal to 2x. So the total, we've got x red plus 2x blue plus 12 green, which is 3x plus 12. So, the probability that both suites are green is 22 over 925. Now, to begin with, we've got 3x plus 12 suites in total, and 12 of them are green. And if I remove one suite, I've got 3x plus 11 now, and the number of green suites I'd have left will be one less than the 12, which is 11. So 12 over 3x plus 12 multiplied by 11 over 3x plus 11 is equal to 22 over 925. So let's manipulate this equation. So we have 3x plus 12 multiplied by 3x plus 11 equals 5,550. And expanding the brackets, we've got 9x squared plus 69x. And if I do 12 multiplied by 11 take away 5,550, we get minus 5,418, and all this is equal to 0. Now if I divide this equation through by 3, I've got 3x squared plus 23x subtract 1,806 equals 0. And now factorising, we've got 3x plus 86 multiplied by x subtract 21 equals 0. And if I solve for x is equal to negative 86 over 3, and x is equal to 21. Meaning x equals 21 is our only solution. Now what we need in this question is the probability of one blue and one red, and that's equal to getting a blue and a red, or a red and a blue. So, blue, that's 2 times 21 over 3 times 21 plus 12, and red, that's 21 over 3 times 21 plus 11. And then, red and blue, that's 21 over 3 times 21 plus 12, plus 2 times 21 over 3 times 21 plus 11. And if I work all of this out, I get 294 over 925.